Me again. In this occasion, I'm gonna show you how algorithms work. Today, we're gonna study the bubble sort, which is one of the most famous algorithms until the moment. But being honest, there are many others, and we can check all of them in a certain occasion in the future. But for the moment, it's more than enough this one, the bubble sort. Now, the bubble sort is good for those people that are, for example, mathematicians, physic people, because the bubble sort teach you how to ordain things, um, comparing one to each other. And you know that in math, um, you do that very often, being honest. So, it is just to sort. What is sort? It's like organized, a sequence of numbers. But I'm going to tell you the truth. If you had, for example, a list of names, and each name has a index. Let's say, for example, that is a list of names for the school, then or for the university, then you will be like, for example, passing the list, having in mind that each one has a number, right? Well, it is the same thing. um, uh, but sometimes the bubble sort comes is when you don't have it organized. The purpose of it is to organize the numbers. In other words, it is not just two numbers, but it is focused in the numbers. So it takes two numbers and it compares. It says, is 7 more than 6? Or is 7 highest than 6? Or is 7 um, with more value than 6? And so on. We can hit on a step and you will see. It says the scales at the right end of the sequence will compare the number on their left and right sides. So at the end, it doesn't matter if the number is at the right or at the left. It will just compare it, and it will say which one of them has more value. You would say, but Reynald, the position matters. Actually, it matters. Yes, it matters. You know why? Let's imagine that you have one in the beginning of the list, and the most important for you, let's say that was one. So when you finish sorting, which one is gonna stay the same? The number one. So the order matters, but it's not like super important. Okay, you know why? Because uh, actually, at the end, it will make the comparison. What it will not make is just the movement of the number, because at the end it will realize that the number is located where it should be. And if it makes the movement, uh, then let's imagine that it takes an space in the memory. The space that it will take would be very low, because it was in a location that actually is the same. So the memory space won't change, almost none. Okay. So in this case, you can see 7 and 6 are being compared, and they are swapped. What is swapped? Swapped means that they are like exchanged, but from location, and especially from position, and um, from the root that is located. Let's imagine that you have one tree and another tree. one is bigger than the other. Um, you would like to swap them. You will interchange or exchange the the location that it is located. That is swapped. Okay? So the smaller will be put on the place that it's supposed to be, close to the smallest on his left, in this case, which is 6. And we can move on. You can see that here it says the same operation are repeated until all the numbers are fully sorted. And that concludes the explanation of the bubble sort. If you want to know, for example, let's show you something that I think that they say at the end that might be important. I don't want you to lose anything, okay? Okay, at the end, look. Here the numbers are again swapped, and it's just saying the same operation are repeated until all numbers are fully sorted. Okay? And here it says just sorting is complete. And that was everything. So, at the end, it was nothing more than that. If you want like an explanation with more details about this, you can leave it in a comment, and I'm gonna leave it to you. Maybe a response, I don't know, to the comment. But I know that there are many people that can explain to this. I mean, I can explain this type of sorting to you. So see you the next time, and remember that Jesus Christ loves you much more than, let's say, a swap. Sorry, it's just having fun. A compass. See you next time.